All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue. Um, we're gonna continue doing ESP32. I don't know why I paused there, like we were gonna be doing something special. We're gonna continue doing what we've been doing for the past couple of days, which is exploring no STD Rust on ESP32 and doing a bunch of electronics stuff, trying to set up circuits and stuff. Oh, give me a second. Right at the beginning of the stream, we are having some, what do you call it? Some dropped frames. So let me just try to fix that. Okay, I think the connection should be stable enough now. There might be one more thing that I might be able to do. I'm not sure if that does help in any way at all, because I don't think anything else is going to be consuming the the bandwidth. I do have a couple of things that might be consuming it, but for the most part, I think we are good. Okay, now before we get into it, earlier today I managed to take out some time to do soldering practice. I actually split it up like over the course of a couple of hours. Every now and then I would go and try different things because I'm still very much a beginner at soldering. What was that? I'm still very much a beginner at soldering, and there's a lot that I have to learn. So whether it's something as simple as tinning the tip, or something like, getting solder to flow from the tip onto the PCB and the component that's through that PCB hole, getting everything to stick properly, not not putting excess, not ending up with solder joints, not ending up with solder blobs, all of these things. Like I was practicing. Why was I talking about this? I think I was trying to say that I'm still very much a beginner. So everything from so even something as simple as tinning the tip, going from something as simple as tinning the tip to something more complex, like actually getting the solder to flow onto the surface and bind to the surface and stuff like that. All of that stuff is very new to me. There's a whole bunch of practice that I have to do. So today, what I decided to do is I can actually show it on stream probably. Well, okay, I'll have to get up and go there. What I did is I have these perf boards and I have header pins that I had ordered separately for soldering onto the various modules that I have. Give me a second. I can probably let the thing cool down a little bit. The matrix rain is going to freeze in the meantime, but it's okay. So, what was I talking about? Yeah, so what I did is you can see the breadboard on cam right now. Just imagine a similar breadboard, and what I did is I put the header pins into the breadboard, and then I placed the perf board on top of those header pins. So that way I would have like a stable surface for the PCB, and the PCB wouldn't move because it would be locked in with the header pins, and the header pins are inserted into the breadboard. So I have a more stable surface to work with, and I'm basically practicing for what I'm going to be doing later on anyways. So it's a win-win. Also, I decided to test out because I still wasn't able to figure out why specifically my knife tip because I have a couple of different types of soldering tips. One of them is the knife tip, which I was told that it works great as like a Swiss Army knife kind of tip, and it has various other good qualities as well that make it useful for multiple different situations, as opposed to a couple of the other tips which tend to have their limitations. Um, why was I talking about the knife tip? I think I was saying that one of them is a knife tip. The other is a hoof tip. A hoof tip is basically just imagine you have like a imagine you have a stick, and you sliced that stick in half, but the slice wasn't straight. The slice was very much diagonal. It was an angled slice. So after you slice the stick, if you look at the cut, how the cut looks, there's going to be like um, a slanted or an angled sort of cut surface there. That's basically what the hoof tip looks like, and um, that has its own advantages as well, because the hoof tip gives you a wider surface for the heat to accumulate on, and that wider surface area allows you to heat up like heat up the surface that you're trying to heat up pretty well. So heat transfer occurs pretty well uh, thanks to that hoof tip. One disadvantage is that it might, in some situations, be too wide, and so if you have like very intricate detailing that you have to do, it might not always work out the best um, because of how wide it is. So as I'm using it, I'll definitely need to be careful. But the good news is that I was able to tin the tip. So I took out a new hoof tip out of the packaging, and I fixed that onto my soldering iron. And then the first thing you have to do after putting on a new tip is tin the tip. So you wrap one method of doing this is you wrap some solder onto, preferably flux core solder. You wrap the solder as a ring around the tip. You make like a coil sort of shape with it. So you would be taking like a fairly long um, string of the solder, and then you just start coiling that around the tip, and after that you start heating up the iron. So you don't heat it up before that. If this is a brand new tip, then um, this is a pretty decent way of tinning the tip, because the first thing you want to do is tin the tip. I don't know if those tips come tinned, pre-tinned, but the first thing you definitely want to do is tin the tip, and after that you can just resume with your regular work, and every now and then keep tinning the tip, keep cleaning the tip as you're working with it. Make sure there isn't any sort of weird buildup on the tip. Make sure that's why you have to keep cleaning it even as you're working. You have to keep cleaning the tip, and once you're done working with it, make sure you tin the tip again, and just switch off the iron at that point. This what I'm explaining right now. This is also something that I had to learn practically, and this is like the only way that I could learn this is by doing this practically. So this is what I meant when I said that, like, I have a lot to learn in terms of soldering, but the good news is, and something that I'm really happy about, is I'm definitely making progress with soldering, and my soldering is actually working. It's by no means perfect, but it's getting there. I have not yet managed to. This is something interesting that happened. I'm glad that I tested out a different tip. I don't know if it's the tip's shape, or if it's something wrong with the tip itself. But it seems like the heat transfer on, or even, and even the, even how well the tip heats up, it seems like with the hoof tip, there's much better heat buildup and heat transfer happening. So like not just the heat not just the heat transfer, there's also the thing that your tip needs to be hot enough that as soon as you touch the solder onto it, it immediately melts on there. That's what I had seen in the various videos that I had watched. Yeah, that's what I'd seen in the various videos that I'd watched. Sorry, I just remembered that the Matrix Rain, I'd paused it temporarily. I didn't actually pause it. What's happening is I have the kitty window being captured by OBS. Within this kitty window, there's the Matrix Rain effect, and that's on the left side. And then on the right side, in the bottom right, is one Tmux window, and in the top right is another Tmux window. So all three of these are they've been set up within one kitty window, and they are being this kitty window is what's being captured by OBS. And then, of course, there's the webcam being overlaid on top of that. So after a while of doing this, CPU starts to the CPU temp starts to increase, and because the temp increases, so the fans start to get loud, and that's why I was like, okay, if I'm just yapping right now, let me temporarily move to one of the other virtual workspaces because I'm on Ubuntu. I have virtual workspace slash virtual desktop. I don't remember what it's called, but it's basically multiple different workspaces that you can operate in. So you can have some windows within one workspace, some windows within another, some windows within another. And whenever you need to, you just, at least in my case, it's Control Shift, no, Control Alt, and then left or right arrow key. So I can very easily words. I can very easily switch between the workspaces um, without having to do something like Alt Tab, which is very convenient. But the thing is, when I switch from one workspace to another, the workspace in which the Kitty window was running, the Kitty terminal was running, in which these three other uh, shells are running, where there's the Matrix Rain and the two Tmux windows, that freezes. As in, it doesn't exactly freeze, but like it's not running. I think that also means it freezes. Yeah, I think that means it freezes. And OBS is actively capturing that Kitty terminal window. And so if it freezes, then that's what's going to show up on stream. It's going to show up as frozen. And fortunately, the webcam doesn't freeze because the webcam is not a window. The webcam feed is being created within OBS directly, and that's what's being captured and broadcast. Okay, okay. So yeah, I've been busy doing a bunch of soldering practice. I Something I still need to figure out, and I think I might need to take out another one of the knife tips that I have. Fortunately, I ordered a bunch, so I have a couple lying around. But something that I noticed is that with the hoof tip, when I heated the tip to 350 degrees Celsius, then or Celsius. I keep confusing the two. Or is it like a American English versus British English kind of thing? Because that tends to happen. I'm used to saying Celsius, but I'm not sure. Give me a second. I'm gonna ask Gemini. How is Celsius? Um, am I even spelling that right? I don't know if I'm spelling that right. Uh, yeah, I don't know. How is Celsius meant to be pronounced? The most standard way is Celsius, okay, Celsius. Interestingly, it is one of those words that frequently gets a hidden sound added to it. You will often hear people pronounce it as Celsius, adding a sh sound, but linguists and scientists generally consider the S sound to be the correct version. Okay, all right. Um, yeah, okay. The sh sound, this likely happens because of the co-articulation where your tongue gets ready for the E sound immediately after the s, making it making it sound slightly slushy. You know what? Okay, we're gonna stick with Celsius then. So, um, interestingly enough, or weirdly enough, either way, it was confusing for me. The hoof tip, when I heated it up to 350 degrees Celsius, it was perfect for tinning the tip and doing any of the soldering work with that tip. But then with the knife tip, that exact same temperature just didn't seem to do the job at all. I have no idea what the reason was for that. I don't know if I actually, yeah, now that I think about it, I'm wondering if I accidentally, because like, okay, here's the thing. The way that the soldering iron is set up, you have a sort of chamber in which you can slot the soldering tip. Actually, no, wait. You have a chamber. Um, you slot the soldering tip. You don't slot it directly into that chamber. That chamber is like a cover. You unscrew it and you remove that cover, quote unquote, and then you put inside it. There's a ceramic tube kind of thing. This is what actually gets hot. This is what actually gets heated, and then the heat from this is transferred to the tip. I I'm wondering if I made a mistake in the way that I placed the tip onto that, because you slot the tip onto disconnected and we are live again. I don't know why that's happening. Give me a second here. I need to open up my stream and make sure that we are still live. Yes, okay, we are still live. We are still live. Huh, okay. 18 minutes into the stream and we are already having these issues. All right, so um, yeah, I'm wondering if I made some sort of mistake in the way um, that I placed that soldering tip, because of which maybe the ceramic tube is not connecting very well with the tip, and so it's not transferring heat very well. I'm wondering if that's the case. I don't know. I'm gonna have to open the thing up and check it again. But yeah, what I did notice is that the only way I was able to get the tip to actually start melting solder onto it is by increasing it to 400 degrees, or maybe 410 or 420 or something. But according to Gemini, that is really high. According to Gemini, that is way too high, and that causes oxidation buildup, which would then lead to solder not sticking to the tip very well. So I have no idea what's going on there. I don't know if um, these two different tips, because of their different sizes, require different temps. But at least with the hoof tip, the what do you call it? Um, at least with the hoof tip, 350 degrees Celsius is more than enough. And the solder melts onto it pretty well. I do have a smaller hoof tip as well. I should try that out actually. Now that I think about it, I should try that out. I do have a smaller hoof tip, and if I find that the hoof tip works well, another one that I haven't tried out yet, and I'm being honest here, the only reason I didn't want to try it out is because I didn't have spares for it at the time. And currently I only have one extra spare for it. Kind of one extra. It's basically it's the chisel tip, and that's an interesting one as well. The chisel tip. Imagine a flathead screwdriver, but just thicker. Like a flathead screwdriver, it ends with like a very steep valley kind of thing, right? Because it's a screwdriver. Um, Actually, no. The bigger ones, the bigger screwdrivers. So imagine the bigger screwdrivers, how thick their heads tend to be. Imagine something like that, but like imagine with a smaller tip. So basically, the chisel tip is something like a flathead screwdriver, but a little on the thicker side. And the way that it's designed, apparently, it's great for through hole component soldering. Specifically because of its design, you're able to get heat to transfer really well onto the PCB that you're doing the soldering on and the component that you're trying to solder to the PCB. Um, I haven't tested that one out yet. I believe it's gonna solve my problem, and if it does, I feel like I might need to order a couple of spare um, chisel tips as well. But I really want to get the knife tip to work out, specifically because of its design. Because the knife tip's design makes it easier to use it to reach into like smaller places. And if I accidentally make a mistake, if I accidentally have like a solder joint or something, uh, I can just I can just run the knife into that and split that solder joint. I don't need to worry too much about the having to desolder and all of that stuff. Of course, at a certain point, yes, I'll have to desolder it, but for the most part, I don't need to worry about that too much with a knife tip. That is assuming I'm able to get the knife tip to work at a decent temperature. I really need to look into this because I'm wondering at this point if different tips require different temperatures or different uh, shapes and sizes require different temperatures. And it's kind of interesting that the oh, you know what it could be? So the one of the things is definitely um, that the flatter and fatter surface of the knife tip, it doesn't seem to get um, heat transfer very well. I have to crank up the temperature for that, kind of like how my CPU temperature is getting cranked up right now. I have to crank up the temperature for that. But even like keeping that aside, I'm wondering if one of the problems that I was running into is the fact that the surface is so small, the surface area that I'm touching to the PCB and the uh, through hole component. I'm wondering if the surface area of the knife tip is so small that the heat transfers really fast, and then there's barely any heat on the iron itself or on the tip itself. Yeah, I'm wondering if that's also I'm wondering if that's also a factor. Either way, I have to do a bunch of more experimentation with this to. Okay, give me a second. I need to switch. Oh, just made a mistake. Oh, what was? Okay, right. Yeah, I'm just gonna let the Matrix Rain pause for a tiny bit. I need to do something about this, dude, because the usually what I like to do is I like to let the Ubuntu desktop be idle for a good, like, I don't know, 10, 15 minutes, 20 minutes before I start this whole, RTMP stream with OBS capturing this window and capturing the webcam and capturing all of this stuff. Before all of this, I let the system idle for a good, like, 20 to 30 minutes. And in that time, the CPU temp reaches down to, let's say, within the 40s, as in 40 degrees. And that's kind of what I'm aiming for. Once it hits that, I know that I'm good. If it goes lower, that's even better. Usually it stays within the higher 30s, so close to 40. So once we are within the 40 range, I know I'm good. And then I can start this, and then the CPU will start to slowly heat up over time. But because I only stream for like an hour and a half to 2 hours, that amount of time that it takes, it's spread out very nicely. And so the how often the fans are going to start to become loud, that kind of varies, but it's not nearly that bad. uh Today it seems to be complaining a lot. Oh, you know what, another thing that I didn't take into account is the fact that my AC is not on. I should try that tomorrow, actually. Yeah, I should try that tomorrow because I feel like that might help with cooling a little bit. Okay, okay. Enough talking about. Wait, we're gonna go back to this. Actually, would it help if I'm looking at this window directly instead of looking at OBS? I'm not sure. I mean, I've switched away from the OBS window to, yeah. Anyways, let's see. Okay, so um, we are hopefully. I don't know how much progress we're gonna make in terms of what do you call it? Doing anything practical with the ADC, because I'm still having like some conversations with Gemini. One conversation that I was having today that I'm actually gonna I actually have to read this myself. I haven't read it yet. Um, so I'm gonna be reading it myself for the first time. I was having this conversation about voltage dividers with Gemini because so one ever since I got into microcontrollers, one sort of issue that I've always had is I find myself trying to go deeper into understanding how the circuit is working and why we are doing things the way that we are doing them. And because I don't know complex analog electronics, and I don't fully have a proper understanding of how the microcontroller circuit itself. Not, I don't mean circuits that we set up using microcontrollers. I mean the microcontroller circuit itself. I don't have a full, decent idea of how that circuit is working as well. My quest for lower level understanding of these circuits, it kind of gets interrupted, or I'm not able to go as deep as I want to. Um, and there's also the fact that when I try to go deeper into understanding, stuff, I slowly start moving from the digital level down to the analog level, and sometimes that can end up wasting time in research that I don't fully know if it's going to benefit me or not. Like, yeah, I'll get an understanding of this thing that I'm looking into and how it works, but is that really going to be beneficial for me? Do I need to go that deep? And also, are there any potential downsides if I decide not to go that deep, and in some cases just stay on a higher level understanding? Like for example, okay, this is a microcontroller. The microcontroller has VCC and ground and a bunch of other pins. One of those pins gives you access to an ADC, so you can, if you have a potentiometer, you can connect the potentiometer's pin 1 to VCC, pin 3 to ground, and pin 2, which is the wiper, you can connect that to the ADC, right? And this way you can get like a reading off of that potentiometer. So this is a good example of me trying to judge where or gauge um, which situations I should be trying to dive deeper into, or rather, in which situations should I be trying to get a deeper level understanding down to the analog level about how things are working. So I always have this issue. I'm going to have this issue. So I kind of need to try and find a middle ground where at a certain point I can just be like, oh, okay, you know what? This is how this thing is working, and we're just going to leave it at that, because if I try to understand this on a deeper level, I'm going to have to take apart or study the microcontroller circuit itself, and I don't have the time or even necessarily the knowledge to understand that kind of a complex circuit. So like at a certain point, I have to be okay with treating the microcontroller as a black box, well, a microcontroller and the dev board that it's on, because the microcontroller that you are seeing here, it's not just the microcontroller itself. The ESP32 microcontroller is a small chip that's on this board. This is a development board. This thing that we have here it's called a development board. The ESP32 chip gets put onto this along with a whole bunch of other components to, support this development board circuit, and let it act as a development board circuit. There's a whole bunch of other components that get put in, but the ESP32 chip itself is much smaller. Why was I talking about this? So I was talking about like the MCU and the dev board. Oh yeah, at a certain point, I kind of have to be okay with treating the MCU and the dev board as just a black box technology. Not because I don't understand things that are going on inside. It's more because if I try to go deeper into understanding things, I'll have to try and understand the circuit, and I feel like that's going to waste a lot of time, and I don't know if it's really going to be that beneficial. So like I feel like when it comes to microcontrollers, I need to establish certain rules that I should follow, just to keep reminding myself that, hey, maybe don't dive too deep into this, otherwise you're going to get really confused. And if that's the case, then my way of understanding the my way of understanding how various things in the microcontroller work, it's going to have to be different. Like my way of researching about it, it's going to have to be a little, I'm going to have to find a different way to um, word my queries, which are majority of the time going to be to Gemini. I'm going to have to find a different way to word my queries each time. Um, and I mean, on the bright side, Gemini, I believe, unless I ask it for a deeper, lower level understanding, I don't think it necessarily goes down to the analog level. And I feel like with microcontrollers, the whole idea is that you don't necessarily always need to go down to the um, analog level. You can remain on a much higher level and just treat certain things as black boxes, where you just know that this is the tech. You don't need to understand how the tech is working. You just understand that this is the tech and this is how you use the tech. These are the various things you can do with the tech, and that's it. There are certain limitations of the tech that you should be aware of, and like that's the kind of mental model that I need to be following in certain situations. Okay, all right. So I asked Gemini this question. I was having a conversation with Gemini, trying to understand the whole concept of like voltage dividers. Um, and I was trying to wrap my head around like, okay, um, fine, we have a voltage divider, right? But okay, let me read out the prompt that I had written, because this definitely helped me. Like the answer that Gemini gave definitely helped me understand things. So I what was my prompt? I said, okay, hey, I'm doing ESP32 projects using no STD Rust. I'm still very much a beginner in both analog and digital electronics. I've been exploring voltage dividers, and I've kind of understood the concept, um, but not fully really uh, understand. Oh, but not fully really understood where and how voltage dividers are meant to be used in various situations. And I'm wondering if I should go deeper into understanding them, or just for the time being understand that I can connect pin 1 to VCC, pin 3 to ground, and pin 2 to whatever I need to read. Also, I've read that voltage dividers are not meant for powering something like an LED, but mainly meant to be used as a signal. I'm having trouble wrapping my head around that concept as well. And even there, I'm wondering if I should just treat this as a high level component that I plug into my MCU circuit and use a certain way, or take the time to go deeper into how things work, eventually getting down to the analog level. You can see where I'm, oh, you can see where I'm at knowledge wise. So talk to me. And then Gemini gave me a good rundown about this, explaining that, yeah, if it's a voltage divider, um, it's not meant to be powering anything. There's also the fact that if you put an LED into the circuit, at one point the LED kind of becomes a resistor itself, and that changes the math. There was also one more thing mentioned about how, because of how current is working, whenever you do add an extra resistance into that voltage divider circuit, apparently that could cause more current to flow in, thereby heating up the other two resistors in the circuit, or maybe heating up one of the resistors in the circuit. Um, hold on. Yeah. So you generally don't want to be using voltage dividers to power something. Most of the time, you want to use it to um, either step down the voltage just so it's safer to read. Which that is a specific scenario which Gemini mentioned, where you might want to measure battery voltage. So because the battery itself might be 4+ volts, so it's risky, directly feeding that into the ESP32, and it's gonna fry the circuit. So you pass that through a voltage divider and then measure it. So that's one of the situations. Another situation is analog sensors, so potentiometers or photoresistors. It mentioned that, okay, when you mentioned pin 1 to VCC and pin 3 to ground, you're describing a potentiometer. A potentiometer is just a voltage divider where the ratio changes as you turn the knob. Inside the wiper, okay, yeah, here it's explaining that thing. And then another use case is logic level shifting. Gemini mentioned that if you have a 5-volt sensor, like some older ultrasonic sensors, and want to talk to your 3.3 volt ESP32, a voltage divider is the simplest way to crush that 5-volt signal down to 3.3 volts so the ESP32 can understand it without being damaged. Then, should you go deeper? Gemini said, for now, you don't need to master Maxwell's equations. I have no idea what that is. So I guess we'll get to that once we get into analog electronics. But you should understand Ohm's law, which is V equals IR. In Rust, no STD terms, think of the voltage divider as a pointer. The voltage is the value, and the resistors are the permissions slash constraints. I didn't really understand this analogy, but that's fine. I can go with it. If you treat it as a black box, you'll eventually run into impedance issues where your ADC reads the wrong value because your resistors are too high. Example, using 1 milliohm resistors. No, 1 mega ohm. I think that's 1 mega ohm. Resistors might make the signal too weak for the ESP32 to sample accurately. My recommendation, understand the voltage divider formula just enough to use a calculator. Then the next steps, since you're using Rust, okay, so that was fine. Then I asked Gemini another question. I gave it another prompt. I said, okay, while we are on this, I want to talk about something else. I never got a chance to go too deep into analog electronics. I plan to at some point later, but for the time being, my knowledge of analog electronics and thus my ability to calculate and understand complex analog and digital circuits is very limited. That being said, I definitely don't fully understand how microcontroller circuits work. I mean the microcontroller circuit itself. So I was talking about the microcontroller chip and the dev board chip, not the circuits that we build using those chips. Okay, so I mentioned, I mean the MCU circuit itself, as in the circuit of the MCU and the development board housing the MCU IC, not the higher level circuits we build using MCUs. So I always find myself wondering why things are done the way they're done and how things are working on a lower level. And I've done really simple analog circuits, but that's all mainly AA batteries, LEDs, and sometimes motors, etc. Nothing complex. So when working with MCUs and building circuits with them, I'm often in situations where I'm curious and want to understand how and why things work the way they work. Because of my, but because of my lack of knowledge, I can't fully dive into it, and I don't always know at what point I should be diving deeper, and at what point just having a higher level knowledge of quote unquote this thing works this way if you do things this way is sufficient. A great example of this thing, no, a great example is this thing with the potentiometer, where pin 1 goes to VCC, pin 3 goes to ground. So we have a direct path from VCC to ground, as in a closed circuit. But then we take a connection from pin 2, which is from the middle of this path, and plug that one wire into the other pin in the MCU. Here I'm talking about the ADC, so we can read stuff from it. Due to my lack of analog knowledge, I'm having trouble deciding how I should go about understanding how things work on the MCU side without having to dive too deep into analog to understand things. Any info and advice you can give me for this, it would be helpful. Okay, so Gemini replied saying, it sounds like you're experiencing the classic human abstraction gap. In software, we're using APIs. You call a function and you don't necessarily need to know how the assembly handles the stack pointer. In electronics, the API is often a voltage or current, but the implementation is always analog physics. Here's a guide on how to navigate this without getting buried in a textbook, and specifically how to visualize the MCU connection. The observer mental model. Okay, you mentioned being confused about pin 2 of the potentiometer going into the ICU. Think of it this way. The potentiometer, pins 1 and 3 create a path for the current to flow. It is a quote unquote closed circuit regardless of whether the MCU is there or not. Okay? Then the MCU pin, the observer, when you connect pin 2 to the MCU's ADC pin, the MCU is not trying to consume that electricity. It is just looking at the pressure, which is the voltage, at that specific point. In the analog world, an ADC pin has high impedance. Imagine a massive pipe of imagine a massive pipe with water flowing through it, which is the pot. The MCU is like a tiny pressure gauge trapped tapped into the side. It doesn't take any water out. It just feels how hard the water is pushing against the gauge. When to dive in, no, when to dive deep versus when to stay on the higher level. Since you are using no STD, no, since you are a no STD Rust developer, your brain likely craves deterministic rules. Here's a cheat sheet for where to draw the line. Okay, interesting. Let's take a look at the cheat sheet. So, if the topic is power, then you stay on a high level you need to, if you just need to provide 3.3 volts to the board, and you dive deeper if your ESP32 keeps resetting or getting hot. Okay? If the topic is resistors, then you stay on the higher level if you are using them for LEDs or pull-ups, and you dive deeper if you are designing a precision sensor circuit. Okay? If the topic is capacitors, then you stay on the higher level if they are already on your dev board, and you dive deeper if you are building your own PCB from scratch. Okay, I can see that. Yeah, I can see that. Because with a capacitor, you would also need to account for its charge and discharge over time, in fact. So not just the fact that it charges and discharges, charge and discharge over time, because it's not instantaneous unless you do something to like instantly discharge the capacitor. Okay, and then if the topic is signals, then you stay on the higher level if you are using I2C, SPI, or UART, and you go deeper if your wires are longer than 1 meter, meaning that there would be interference. Okay, the strategy. Treat the MCU and its dev board as a black box with a data sheet. You don't need to know how the transistors inside the ESP32 silicon work to use them. You only need to know the input/output characteristics. Example, this pin can only handle 3.3 volts and 12 milliamps. Then, understanding the MCU side. You asked how to understand, dude. I guess during today's stream we are mainly just reading my conversation that I had with Gemini because yeah, I was planning on, you know, reading this off stream anyways, and we are trying to get an understanding of this. I need to get an understanding of this before, because I have this thing, right? I'm curious about stuff. I want to know what I'm doing and why I'm doing it before I do it. I've always had this problem, and it's not always enough for me to just understand that, oh, this is how things work, and just be okay with it. But in this case, I kind of have to make an exception, because if I don't make that exception, I'm going to end up wasting a lot of time and energy trying to understand something that I may or may not even use later on. And the programming analogy that Gemini gave, which is like, Rust versus assembly, that's a good analogy here as well, because microcontrollers were not built so that you have to understand the entire microcontroller circuit and then do something with it. They were built so that you can much more easily program, you can much more easily create programmable circuits. They were created to increase the accessibility within electrical engineering. So, or well, I'm not going to say that was the main reason why they were created, but their creation definitely did increase the accessibility in within electrical engineering. It definitely lowered the barrier to entry for electrical engineering, and that is why a lot of schools are able to get kids into electronics very quickly, because of microcontrollers. So they can just teach them that, okay, these are analog electronics rules. These are like some simpler analog electronics rules. Once you understand this, you can set up a basic circuit. These are just very basic things that you should keep in mind when you're working with a microcontroller. Just your basic, uh, let's say, Ohm's law for your calculations for various purposes. Whatever the capacitors calculations are, we're going to have to take that into account as well. Whatever the transistors calculations are, and also other simple safety things like, okay, if the microcontroller is very clearly meant to operate at only 3.3 volts, don't feed 5 volts into it. Do something to step down that voltage. I forgot why I was talking about this. Yeah, microcontrollers have lowered the barrier to entry into electrical engineering. So my point is that with microcontrollers, they aren't necessarily meant to, like, you're not necessarily meant to understand the entire circuit. Just like how if you're writing Rust code, you don't need to understand all of the assembly that it's going to compile down to. It helps to learn assembly because it's going to teach you a lot. I learned assembly and it taught me a lot about how things work on a lower level, but you don't absolutely need to do that, right? This is just me, like, this is just me convincing myself that I don't need to do it. Like, I'm, anyways. So, I need to make an exception here for the sake of saving time and saving energy, and for the sake of being able to continue making progress with this thing that I'm trying to make progress with, so I can build higher level things. For the sake of all of this, I need to make an exception and just stop the curiosity at a certain point and just like understand this. I feel like I need to create a sort of, you know what? I'm gonna ask Gemini to give me a very specific prefix that I can add to my prompts, any future prompts that I'm giving Gemini. Um, you know what? I don't know if I'm gonna need that. I was about to say that, okay, I'm gonna ask Gemini to give me to generate a sort of prefix prompt that I would attach to any future prompts that I give to Gemini regarding ESP32 circuits. And that prefix prompt is going to mention that we should treat the MCU as like a, black box technology, and I don't have very high level or very advanced. I shouldn't say high level because low and high level mean, well, low level and high level, they kind of mean something different in this situation. So I'm going to say advanced. So we need to keep in mind that I'm going to tell Gemini the prefix is going to the prefix is going to tell Gemini that we need to keep in mind that I don't have a very advanced understanding of analog electronics, and I'm still very much a beginner in analog electronics and also digital electronics. So we should kind of stick to higher level concepts without ending up going down to the analog level to understand things. But what I'm wondering is if I'm even going to need that or not. Because, like, if I just ask Gemini a question, Gemini usually gives me a higher level answer, at least when it comes to microcontrollers. Gemini gives me an answer on the level where it's supposed to give me the answer, because what it answers in is from a point of view that you are operating a microcontroller circuit. You are operating a microcontroller that has a certain set of behaviors, and keeping those behaviors in mind, Gemini answers accordingly while keeping things on a higher level. So I'm still going to get Gemini to generate that prefix for me, the prefix prompt, but I doubt I'm going to need to use that in many situations. I'm still going to hold on to it just in case if I ever need it. Okay. All right. Understanding the MCU side. You asked how to understand the digital side without the analog deep dive. Focus on the threshold. Digital electronics is just analog electronics that decided to be binary. Inside the MCU, there are CMOS transistors that act like switches. If the voltage is above a certain point, the transistor flips on. If the voltage is below a certain point, it flips off. You only need to care about the analogness, quote unquote, analogness of it when the voltage is stuck in the middle, such as the floating state. This is why we use pull up or pull down resistors to force the pressure to a known high or low state, so the quote unquote switch isn't rattling in the wind. Okay, so this, yeah, I'm gonna create the prompt for this one later on because I feel like I need to create a new prompt where I'm gonna tell Gemini this exact same thing, that hey, this is the situation with me. I want you to teach me everything about microcontrollers, specifically ESP32, but microcontrollers, keeping this limitation of mine in mind, and teach me how I should be thinking about this when I'm trying to understand ESP32 related stuff or microcontroller related stuff. Teach me how to understand this. Teach me how to go about doing my research in such a way that I don't go down to the analog level unnecessarily, unless absolutely necessary. But yeah, that's going to be a different prompt. I'm going to set that prompt up later on. That's going to be a new conversation as well. Okay. You only need to wait. That was a floating state thing. Yeah. The reason I want to make the new prompt is oh wait a minute. Yeah. The reason I want to make the new prompt is because looking at that CMOS thing and this floating state thing, it reminded me that, yeah, there are various things about microcontrollers that I don't fully understand. And I feel like there's also stuff about digital electronics that I don't fully understand. So I'm going to craft a new prompt and ask Gemini to explain this to me and just teach me everything about it. And fortunately, daily, um, Gemini does give us a couple of. So, like, if you're using Gemini from the web, dude, I'm not even kidding when I say talking to LLMs has helped me make progress so much faster than if I would be stuck Googling things on my own. It is insane the amount of progress that I'm making. And even this, I'm not fully satisfied with the speed at which I'm going. I still want to further speed this up because I know that I can further speed this up, right? Even now, I'm not satisfied with the speed at which I'm going, but it's crazy to think about how if I wasn't using an LLM and I had to like Google shit myself and Google shit myself. Okay. Just Google things myself and what else? My little slip up there made me forget. Google shit myself. Okay, okay. No. Um, wait. It's. I'm losing it. I'm losing the train of thought. Hold on. I need to get it back. What were we just talking about? Um, what what were we just talking about? We were just talking about something. We were just talking about Oh yeah, I was talking about like how if I didn't have access to an LLM, I would be stuck Googling all of this stuff, and I would have to like get bits of knowledge from various different corners of whatever forums and Stack Overflow and Stack Exchange. And even then, like, I would have a hard time understanding how much of that applies specifically to my situation. Whereas with an LLM, I can explain to it that, hey, this is what I'm trying to learn. This is exactly what I'm using. This is my exact level of knowledge. Keeping this in mind, here are my questions. Help me out with some information and advice. And then I can get the most accurate information that the LLM is able to provide me with. Give me a second. Holy shit, today's entire stream has been just yapping, which I'm not complaining about that. That's great. Okay. Continuing. Okay, this is why we use pull up or pull down resistors to force the so and so. Okay, yeah. Then a pro tip for your ESP32 slash Rust journey. Since you're doing no STD, you'll eventually encounter peripheral access crates and hardware abstraction layers. Yep, true. Uh, the PAC is the analog to digital bridge. It deals with specific memory addresses, which are registers that represent those physical voltages. The HAL is your high level comfort zone. My advice: don't study analog electronics as a whole. What? No, don't study analog electronics as a whole. Study, quote unquote, the interface. When you use a new component, such as a sensor, a motor driver, a screen, look at its data sheet for the electrical characteristics table. If it says input high voltage, 0. 0.7 multiplied by VCC, that's the only quote unquote analog math you actually need to solve to make your digital code work. Would it be helpful if I explained? Oh, okay, this is, yeah. Right. Okay. So I'm going to ask Gemini for a prompt. Okay. In the future, um, if I want to wait, no, no, no. Let me say, okay. So keeping this in mind, in the future, if I want to, if I want to ask you, wait, keeping all these details in mind, in the future, if I want to ask you something relating to building an ESP32 involved circuit and or well, yeah, building an ESP32 related circuit. I feel like I should give you a prefix along with, or well, this would count as a preface along with my prompt. What do you suggest the preface to be? To make our future collaborations as smooth as possible, your quote unquote preface should act like a configuration file for my responses. It tells me exactly where to sit on the spectrum between high level API and low level physics. True, true. Here's a template you can copy and paste or tweak when you start a new technical thread with me. The ESP32 context, the ESP32 Rust hardware context preface. Context. I'm working on an ESP32 no STD Rust project. Knowledge level, comfortable with systems programming, beginner in analog/digital electronics. The goal, I want to understand the interface between the hardware and my code. Depth, wait, this is interesting. Gemini is teaching me how to create the prompt for it. And this is reminding me that we were supposed to be learning that, we were supposed to be going through that LLM course, and I never did that. That's crazy, dude. Real quick, let's go back to the mind map just to see what more was remaining. So ESP32, wait, look up this. We don't need that anymore. We still need to read this, understand exactly what ESP HAL does. I'm glad that I looked into this because I understood this on a deeper level. This and embedded graphics as well. It's really interesting how each of these works because, so with embedded graphics, the way that it works is, and I'm trying to explain it to see if I've understood it myself as well. But yeah, the way that it works, as far as I've understood, is generally embedded graphics provides an interface that you would that any graphics driver that you are implementing, uh, any graphics driver that you are writing would need to implement. So any graphics driver that you are writing for, let's say, a TFT display, a very specific TFT display, because each of these display modules, they have their own circuitry. These are entire modules. It's not just it's not just the display that you get. They have like their entire systems built into them, and there's very specific communication that has to happen. All digital. It's not even analog. At least not to my knowledge. A lot of it, most of it is digital. So when you're programming them, you're actively sending bytes of data, or at the very least bits of data. You're not dealing with like analog signals. So these things are usually programmed. First, you have to configure them in a very specific setup, or you have to power them on in a very specific configuration, and then you can send them specific sequences of bytes to program them in a certain way, or to get them into a certain configuration. And depending on what the configuration is, or whatever mode you have set, you'll be able to give them different you'll be able to give them different commands to do different things. And each of these TFT display modules, regardless, it doesn't have to just be a TFT, but like TFT is one kind. And even within TFT displays, you have different models being made. So you have different types of TFT displays. You have different types of OLED displays. You have those old monochrome screens. So you have those kinds of displays as well. A lot of these, like they all work in different ways, right? So if you're writing a driver, you would be writing a driver for one of these devices specifically. But thanks to embedded graphics, you can write the driver. Um, you can write the driver for you can just write the driver. That's what I'm trying to say. You can just write that one graphics driver, and it should work across multiple other microcontrollers, because embedded graphics, it it's tightly knit with embedded HAL. That's what it was called, right? Embedded HAL. I think so. Yeah. So embedded graphics is tightly integrated, or not tightly integrated. It heavily uses embedded HAL. So if you have implemented if you have written a driver that is implementing embedded graphics, then you that driver will be usable with any HAL that implements embedded HAL. So in this case, something like the ESP32. But if I'm understanding this right, because of the way that this whole thing is set up, you could easily take that driver code that was written for embedded graphics. Because it's written for embedded graphics, you can take that exact same driver code and plug that um, into your let's say Arduino Arduino Uno code. I'm just putting that out there. I don't know which all devices embedded HAL supports specifically, but yeah, just we can say Raspberry Pi Pico. I think that's a microcontroller. But yeah, that's because of how these things are set up. If you write the driver once, the graphics driver once, you can then use it across these multiple devices because you can use you can use it across every device that that implements embedded HAL. So ESP32, it uses the ESP HAL, which is an implementation of embedded HAL, or it's an implementation that uses embedded HAL. Okay, all right. Now, we are looking at this. I believe it's in things to do. So what all did we have here? We have the content pipeline. Okay, that's still in the works. Um, finish learning Rust, dude. I did not finish learning Rust. But it's crazy how, despite me not having finished learning Rust or not having gone into all of the advanced concepts that I would like to have gone into. Despite that, I'm still able to use Rust pretty regularly at this point. Granted, because of my lack of advanced knowledge, any advanced thing that I do implement or try to implement using Rust, it's not going to be the best. But for the time being, I'm able to just use Rust. I've gone far beyond beginner level where I make like syntax errors and stuff. Now I'm actually able to track errors down whenever there's like oh there's a move error over here. You're trying to use a value. You're trying to use a variable after the value is moved out of it. I'm able to track all of those things down. So like I'm past the point of being a complete beginner in Rust, but I wouldn't say that I'm completely done learning what I consider to be the basics yet. Either way, I'm happy with the progress that I've made. I definitely want to continue making progress on this. So we need to continue that Gemini course. Okay, Godot with Rust. Holy shit! This literally just got pushed to the side, but I do want to continue this as well because I want to do game dev stuff. But to be honest, considering what we are doing now with this, with the electronic stuff, I am gonna have to see at what point I'll get back into Rust, not Rust, into Godot with Rust, because there's a bunch of other stuff that we need to be doing. Um, there's all of this stuff, dude. Where is it? Oh yeah, all of this. There's the Hugging Face LLM course. There's the Hugging Face Agents course. I decided to go with Hugging Face instead of going with Gemini's, what do you call it? Instead of going with Gemini's agent course, I decided to go with Hugging Face Agents course. Then there was Ractor. I need to finish learning Ractor because I liked the concept that was introduced in Ractor. Prior to this, I'd never actually used an actor model. That's what it's called, right? I believe so. An actor an actor framework, an actor model, basically where you set up actors to do various jobs, and you can set like parameters and conditions and customize their working mechanisms in various ways. But in the end, these are separate actors that are doing that are doing separate jobs. And I feel like doing this on Rust is going to be highly beneficial, because the fact that it's running on Rust means it's already going to be running fast. So even if there's a tiny bit of overhead introduced, I wouldn't need to worry about that too much, unless I absolutely need to squeeze like all the power out of my hardware for something that I'm working on. I think I can get away with quite a bit if I if I start using some sort of actor framework. There's another thing. So I came across Ractor, right? But when I actually looked into Rust-based actor frameworks, Ractor wasn't the only one. There were a couple of others that had popped up as well. And I need to now do some research on which one of these would be considered the best for me to work with. I know that Ractor runs on Tokyo. So if you need to do async multi-threaded stuff, which if you have multiple actors, then there's a chance you might want them to run on different threads. Because it's running on Tokyo, so you get a bunch of the benefits of Tokyo. Stuff like way beyond just being able to do async and multi-threading. You get a lot more of like the niceties of it, being able to like interact between threads. That's one of them, but there's a bunch of others as well. Tiny Skia. I need to continue with this. Yeah, I need to continue with Tiny Skia, because this is for the VTuber application. The thing is, I'm gonna learn Tiny Skia. That's for sure. It's a very tiny library, and I'm glad that it's a very tiny library. That means that learning it is going to be relatively simpler for me. It's not gonna use up too much of my time. I have already like started using Tiny Skia. I set up a um, I think I did show it on stream. I don't remember. I think I did. I think I did show it on stream. I can't remember exactly, but I'd worked on a tree map generator, and because of Tiny Skia, I was able to practice. Well, because of Tiny Skia, I was able to render this tree map, and that gave me an excuse to actually practice Tiny Skia. So that gave me a tiny bit of experience with Tiny Skia. But there's a lot more that I need to do with this library. I need to explore everything that it has, because this is what's eventually going to be drawing my VTuber model. And then the next step, after the thing has been drawn, the next step is to convert it to what do you call um, Ratatouille. There you go. Um, the next step would be to convert whatever that graphical representation is to something that Ratatouille can actually interpret and display as terminal based graphics, as TUI based graphics, basically terminal based graphics. That's how I want my VTuber model to be. I want it to be something terminal based. So Ratatouille is mainly going to be responsible for that one thing. At least for the time being, that's the way that I've set things up. But because this is a TUI framework and this is my VTuber app, so I do have the option to add a bunch of other things if I want to, if I need to. For the time being, the main objective is to make it a VTuber application, and then I guess after that we can move on from this VTuber app, we can kind of, I guess the right term is sunset it. We can sunset this version of the VTuber app and move on to the new version. And yeah, okay, so that's Tiny Skia. I noted down a whole bunch of things that I wanted to learn. Then, sorry, I'm feeling like sneezing and I keep having to like keep sniffling. Okay. Um, then learn polars. We are doing that. I'm definitely going to continue that because that is we need that. We need that. This I don't know how much of this is going to happen now. Actually, this I feel like I haven't been keeping up with this. I this is all like older. This is all older stuff. Right now we have this. Oh, I was supposed to set up the upload script, but that's part of working with the content pipeline. Thanks to Gemini, I should be able to create a more up-to-date version of that upload script, which is surprising that they haven't updated that at all. Like, dude, the example that is from official Google Docs about this, like official Google API documentation that's giving an example of uploading a YouTube video. The official example is like a decade old. The official example is so old that it's using Python 2. That's so surprising, dude. That is surprising. I don't know if I just did a horrible job of doing research on this, or if they've done a horrible job of keeping this specific thing up to date. But like, damn, dude. Well, either way, fortunately, I have Gemini, which can, you know, easily convert this script for me and clear out all the older stuff, maybe add some improvements, remove any sort of noise from it, and add in the customizations that I want. Yeah, yeah, hold on. Learn keyring in Python and Rust. But more specifically, I'm focusing on Python because, um, wait, no, hold on. I need to, no, 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 I need to focus on both Python and Rust because there are different situations where I'm going to be using Python and different situations where I'm going to be using Rust. For example, I do need to write a tool that's going to pull all of my um, Twitch VOD titles because each of the VOD titles that I set up, I usually note them down each time that I download the VOD. I side by side, I also note down the VOD titles, and it's a bit tedious if I'm being honest because the way that their UI is set up, I have to first start that download. I have to first start the processing step where like I'll click download. So like, okay, I go to my video producer. In the video producer, um, next to, so like all of my VODs are listed there, right? Next to each of the VODs, there's like a little three dots menu kind of thing. I have to click that and then click download. It's not going to instantly start downloading. What it does is it prepares the file that I'm going to then be able to download. Once the file is ready, which takes usually a couple of minutes, once the file is ready, it loads up that file that their servers are allowing me to download. It loads up and starts playing that file. So now I have access to that file and I can use that link and then use a tool like curl, for example, to pull that entire video. That's how I download the VOD, right? And then if I want to copy the the title, I can't just like use my mouse and copy it because that doesn't work with their UI in the video producer. if I try to if I try to copy the title, it'll click on that and then it's going to open up the video in like a little side panel kind of thing. Then I have to scroll down and then click on the title field and then copy the entire title from there. Then I have to hit cancel to go back and then wait for this video, which was previously, being processed. I need to wait for that to start up so I can then start the download. And I have to do this for each and every VOD. So the process of noting down the titles is very tedious. At the very least, I have access to functionality that will allow me to pull all the VOD titles. I know that because the Twitch API allows that. It allows you to pull details of VODs. So I can write some logic to pull all of that information in one batch and then just do a bit of copy pasting to add those titles into my vodtitles.json file. This way, I don't have to worry about those extra steps that I have to take just to copy the VOD titles, and I'm also going to be populating my input titles.json file. Okay. I've been yapping a lot. I have a lot of more yapping to do with Gemini. Yeah, but that's gonna be it for today's stream. I'm gonna be ending the stream here. I don't think I'm gonna raid anyone today. I'm just gonna end and then I'll continue with my research. Yeah, that's gonna be it for today's stream. We didn't do any ESP32 coding, but we did a lot of, we did a lot of, holy shit, why was I, man, I need to, yeah, okay. We did a lot of ESP32 related research. We didn't do any coding or, practical circuit stuff, but we definitely did a lot of research, and I have a lot more research that I have to do. Hopefully tomorrow we will actually do something ADC related. Let's see. But that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.